Hi, I'm Emma. I'm at the University of Bath in the Creswell group. So I'm a fourth year PhD student. I did do my undergraduate here, so I'm also been here for 9 years in total. I've been working on the synthesis of alpha arylated pyrrolidines.
Hi, I'm Callum. I'm quite the opposite to Emma. I'm a first year PhD student here in the Creswell group in Bath, but we're similar in that my research is also focused on the synthesis of alpha arylated pyrrolidines. The Creswell group in general is focused on taking amines, which are abundant chemical feedstocks, and functionalizing them to give molecules which could be used in the drug or agrochemical industry.
So for my PhD work, to make my starter materials, I use photoredox catalysis, and I want to make large amounts of these, so on multi-gram scale. So for this, I'm using the PhotoSyn reactor. So I make these in flow, and I'm able in just a few hours to make multiple grams of the starter material.
And when we do chemical reactions in chemistry, we tend to use what's known as a solvent, which is a liquid that you kind of run the reaction in. And Asynt provide an excellent piece of equipment called the spiral evaporator, which we can use to remove solvents which have a really high boiling point. So it's been very influential in our research to enable us to use solvents which we otherwise could not.
I'm working with amines, and I'm changing the reactivity of the amines. So instead of reacting at the nitrogen where I would like to react, when I'm using photochemistry, is reacting at that alpha carbon to the amine. And then, we need to use flow for this, because if I was using it just in batch, the nitrogen might react if it's not in flow. And also you only can do these on very small scale on batch, because you need to have the light penetrate into the flask. Whereas in flow, you can leave it going for hours and keep the reaction going for longer and make larger amounts. Working in Bath has been really good. The chemistry department here is all on this one site, and everyone's really friendly, so we're able to work between the different groups. So actually I've been working with other groups in, say, biology as well, which allows us to diversify what we do, because everyone's friendly and we can just chat to each other and learn new techniques quite easily.
Yeah, it's great. I mean, Emma has been here 4 years or 9 years in total. I mean, if you count your undergrad, I've only been here a few months, but even so far, the group and the department in general has been so welcoming. It's been great, as Emma mentioned, to work with other groups in biology and to see applications of what our chemistry can actually do in the real world, per se.
Working in Bath is amazing. So the university here is just sort of outside the city centre on campus. So we have a lovely lake and lots of green area, which is really nice, particularly in summer, to sit around the lake and have our lunch. But it's also walkable into the city centre. So we're able to go on a lot of group socials at the weekend to cafes, or in the evening to pubs or to restaurants, all within walking distance. That's been really nice to be able to do.
Since starting my PhD here, Alex has been a real influence in terms of the chemistry that I've become excited about. And in terms of my development as a chemist, it's been really great to have his support in what we do here.
I agree. So I say, starting with my master's here in the Creswell group, so Alex really supported me and helped me grow as a chemist, and that's continued into my PhD. So we can have weekly meetings with him. Any questions we have, he's always happy to answer any of our questions. And talk about our future and what we might want to do afterwards as well.
The facilities here in the Creswell group are really second to none in terms of academia in the UK. It's really something that sort of drew me to the Creswell group, and the different bits of equipment, the flow chemistry, the different ways we can remove solvent are just really influential in the way that we can carry out our chemistry. And it really enables us to do the research that we enjoy. We like to use abundant feedstocks, mainly amines, in our chemistry. And we can take these amines and functionalize them within different ways. And photochemistry is essential to this. In terms of normal reactivity in chemistry, with heating of substrates, you can get them to react in one way. If you treat them with light, you can react them in a completely orthogonal way. We like to use these functionalized amines to create different spiral cycles, which are chemical rings joined together. And usually to make these types of ring systems, you would require heavy metal catalysts, which can be, on one hand, very expensive, and on the other hand, are not very prevalent within nature. And so mining of these and other methods to get near the nature can be very damaging. So what we like to do is to create these different systems using photochemistry to remove the reliance on these heavy metal catalysts.